calculate the mean of x and y, to compute the mean of x, it will be 10 plus 15 plus 20, all divided by 3. And that should be 15. To calculate the mean of y, it will be 10 plus 20 plus 30, all divided by 3, and that should be 20. What is the sample standard deviation of x, and what is the population standard deviation of x? The formula for sample standard deviation of x would be the square root of the summation of xi minus x bar squared all over n minus 1. For population standard deviation of x, it will be the square root of the summation of xi minus the population mean squared all over n. So the major difference between what we have here and here is this. This has n minus 1, but this is just n. So to compute sample standard deviation of x, it would be xi, that's x1, which is 10 here, minus x bar, which is 15, squared, then plus 15, the 15 is coming from here, minus that of the mean, that's this, which is 15, squared, then plus 20, minus the mean, squared, all divided by n minus 1. N is 3 from here, that's 3 minus 1. Then you can find the square root of the whole of this. If you solve for this, I expect you to get 5. So I have 5 here. Moving on to population standard deviation of x. So it's the whole of what we have here. But the major difference is now, instead of dividing by 2, we will divide by 3. Then we can go ahead to find the square root. Raising the whole of this to the power of 0.5 is the same thing as saying square root. I expect you to have this. Now moving on to that of y, you can solve for this using the same method. For the population standard deviation of y, you should have this. This is for the sample standard deviation of y. Now let us move on to covariance. The covariance between x and y can be computed as, so covariance between x and y is the summation of x minus x bar, xi minus x bar, then times y, I minus y bar, divided by n minus 1. In case you are struggling with this formula, a better way to recall this formula is to recall the formula for variance. Variance is x minus x bar squared. Obviously, there will be summation here all over n minus 1. But when it comes to variance, let's say the variance of x, here x is moving against x. Just so that we are all on the same page, if I want to expand this, I can expand it as x minus x bar times x minus x bar, and I can close the bracket. So this implies that x is moving against x. But for covariance, it's the movement of x against y. So if that is the case, I can rewrite this formula, and I will change this to y if I'm interested in the covariance of x against y. So I can change this also to y bar, and this is obviously my formula for covariance. So we need this table to help us out. So x1 is 10. So 10 minus x bar is 15. So 10 minus 15, that will be minus 5. 15 minus 15, that will be 0. Then 20 minus 15 will be 5. For that of y, y1 is 10. 10 minus 20, that's minus 10. y2 is 20. 20 minus 20, that's 0. Then 30 minus 20 would be 10. So we need to multiply what we have here by this because that's the formula for covariance. The formula for covariance is xi minus x bar times yi minus y bar divided by n minus 1. So that means we need to multiply this by this, then we can now add them together because of this summation. So it will be minus 5 times minus 10, which is 50. 0 times 0 is 0. 5 times 10 is 50. If you add all of these together, you should have 100. So it will be 100 divided by n minus 1. So our n, this is one pair, this is another pair, this is another pair. So our n is 3. So it will be 3 minus 1. So our covariance is 50. To compute correlation, correlation R is covariance of x against y all over standard deviation of x times standard deviation of y. In case you are struggling with this, a better way to recall this formula is to note that covariance is unstandardized. It could assume any number, but correlation is standardized. Correlation ranges from -1 to +1. So we have computed covariance already. Covariance from what we have computed is 50. So that will be 50 divided by the standard deviation of x, which is 5, times standard deviation of y. We have computed it, which is 10. That implies that our correlation will be 1.